Hey guys, welcome back to another video. I've already done questions 1 through 30 in other videos. I'll link those in the description. And I'm going to be doing questions 31 and onwards in this video from physical chemistry. So yeah, let's start. Question 31. 2 moles of VO2 plus vanadium oxide ions react with 1 mole of zinc atoms in the presence of dilute acid. The products include zinc ions and an ion Y. Ion Y contains vanadium. Only zinc and vanadium change oxidation state in the reaction. What is ion Y? So ion Y is an ion which contains vanadium and oxygen. So basically it's a redox reaction. You don't know the formula of Y, but you have to figure that out. So let's write the equation first. You know 2 moles of vanadium oxide are reacting with zinc and reacts with acid, dilute acid. Okay. And this forms zinc ions, positive zinc ions, and Y. Okay. And in return, it's going to give you a water molecule to balance the equation out. Okay. So the first thing you're going to notice is zinc is losing 2 electrons. Zinc is losing how many electrons? 2 electrons. 2 electrons. And those 2 electrons are going to be gained by another species. Which could that be? Vanadium oxide. Vanadium oxide. Vanadium oxide has a charge of 1 positive. Yeah, positive 1 charge. So in that case, if we take the charge of vanadium as x minus 4, since oxygen has a charge of minus 2 and there are 2 oxygen atoms, minus 2 times 2 is going to be minus 4. Minus 4 is going to give you a plus 1 charge. X is 5, positive 5. That's why vanadium has a positive 5 charge. Okay. Now, one thing that you should notice is there are 2 moles of vanadium oxide, and on the right hand side there should be 2 moles of Y as well, because all of these options, there is 1 vanadium, 1 vanadium, 1 vanadium, and 1 vanadium. So to balance the number of vanadium atoms, you have to give 2 Y ions. Okay, once you do that, you're going to notice that vanadium has to get reduced. Why? Because zinc is getting oxidized. Zinc is getting oxidized to a state of 2+. Since it's losing those electrons, another species has to gain those electrons. And which could that be? Vanadium oxide. And which atom is going to be gaining? Which ion is going to be gaining those electrons? Vanadium plus 5 ions. So it's going to be going from either plus 5 to plus 4 or plus 3, or whichever option you have. You have 2 options, plus 3 or plus 4. Okay. The others are not going to be viable since they're getting, either they're not changing their state or they're getting oxidized. Plus 6, they're getting oxidized. Plus 5, they're not changing their state. So A and D are not going to be the options. It could be between B or C. Now, what if B was the option? What if we consider B? If you plug B in for Y, if Y was VO plus, here vanadium has a plus 3. And since there are 2 moles of Y, you would be gaining a total of 4 electrons. Since 2 electrons were lost, and since vanadium is going from a state of plus 5 to plus 3, plus 3, plus 5 to plus 3, it needs plus 2 electrons. But how many vanadiums are there? 2 vanadiums. 2. Therefore, it would need to be 4 electrons. But you don't have 4 electrons, do you? You have only 2 electrons, for which B cannot be the answer. B cannot be the answer. That is why C is going to be the best option. Why? It is going from a state of plus 5 to plus 4, where it's gaining only 1 electron. And since there are 2 moles, 2 times 1, 2 electrons are needed only. And that balances the entire equation. So the number of electrons are balanced and the equation is balanced when you're plugging in C. So the right answer is C. Okay, question 32. The enthalpy change of reaction 1 is minus 114 kilojoule per mole. What is the reaction? It is a reaction between sodium hydroxide and sulfuric acid, forming sodium sulfate and water. By using this information, what is the most likely value for the enthalpy change for reaction 2, where barium hydroxide is reacting with hydrochloric acid, forming barium chloride, which is aqueous, and giving you 2 moles of water molecules. Okay, so the first thing is, let's consider the first equation, reaction 1, and they've given you the enthalpy change for that reaction, which is minus negative 114. 2NaOH plus H2SO4 giving you Na2SO4 and 2H2O. Great. Now, the most important part in this question is all of these are aqueous. All of these are aqueous. Water is going to be liquid, since that is the solvent where all of these reactants and products are dissolving in. So, the first thing you have to figure out is that all of these sodium and sulfate ions are spectator ions. They're not taking part in the reaction, because from the beginning there are sodium ions, there are sulfate ions, and even after the reaction is taking place, there are sodium ions and sulfate ions. They have not formed any kind of bonds in the equation. They have not formed any sort of bonds in the equation, since they are still in aqueous form. If it would have been gas or solid, it would have been different. Then you would have to consider the enthalpy change for this as well. If it was solid, I mean insoluble, or gas, then it wouldn't have been minus 114. This minus 114 is actually the enthalpy change for forming the water molecules, for forming 2 moles of water molecules, where the ionic equation is H plus OH minus, giving you H2O. Since 2 moles, you can just do this, and you're going to have an enthalpy change of minus 114. So this is the main equation. This is the actual reaction that is taking place, where there are bonds being formed. So this is an exothermic reaction, where energy is being released. Why bonds are being formed? Which bonds? For water molecule. Other than this, there are no other bonds being formed or any other reaction taking place, since all of the above are spectator ions. They're not taking part in the reaction. So they're not contributing to the value of enthalpy change. Okay, so they've given you minus 114. For the next reaction, it's the exact same case, where barium ions are spectator ions, chloride ions are spectator ions. They're not taking part in the reaction, since barium chloride is aqueous. They were in aqueous form at the beginning. They're in the aqueous form at the end as well. They have not changed anything. There are no bonds being formed, so they're not contributing to the to the value of enthalpy change, which is going to be exothermic as well. Why? Because 2 moles of water molecules are going to be formed. Okay, so for that, it's going to be the exact same value. The exact same value. Why? Initially, 2 moles of water in reaction 1, 2 moles of water molecules were formed. In reaction 2, 2 moles of water molecules were formed. So the answer is going to be minus 114 kilojoule per mole. Since the ionic equations are the exact same, the enthalpy change is going to be the exact same as well. That's it. Okay, question 33. A student adds 3 mole of acidified potassium chromate to an excess of iodide ions. The chromium is all reduced to chromium 3 plus ions, and iodide ions are oxidized to iodine gas, or iodine molecule. So if we look up till this part, the first part, potassium chromate is added to an excess of iodide ions. Okay, so let's figure out charges on each of those. Oxygen has a net negative of -2 charge. Chromium will have, you don't know that. Potassium has +1, but since there are 2, it's going to be a total of +2. And since oxygen, there are 7 oxygen atoms, it's going to be -2 times 7, which is -14. You don't know x, but there are 2x. Chromium. I'm representing chromium as x. So, +2 plus 2x minus 14 is 0. So, if you make x a substitute, it's going to be 6. So, chromium has a charge of +6. Okay. When writing the equation, you can take potassium out of the equation. Since potassium is not gaining or losing electrons, so it's not going to be affecting the equation. So you can take potassium out of the equation, and yeah. If you take the chromate ion, which will have a net negative of -2 charge, since you have already taken potassium out of the equation. Potassium contributed by giving a +2 charge. So if you take that +2 charge out, you're going to be left with net negative charge of -2. That's why -2. You can keep potassium as well. It's not going to be affecting the equation, but it's just simpler if you take it out of the equation. So you have chromate ions and you have iodide ions. They have already mentioned chromium turns into Cr3 plus, where it's gaining 3 electrons. Okay, it's gaining how many? 3 electrons. 3 electrons. How many chromium ions are there? 2. Multiplied by 2, you're left with 6. So it's gaining how many electrons? In total, 6 electrons. So you didn't know the molar ratio or the moles of iodide ions. You can use this value, which is 6, as a way to figure out how many iodide ions are needed. So how many are there? 6. Because each iodide ion is contributing by giving you -1 charge or 1 electron. So how many electrons do you need? How many electrons do you need? 6. So how many iodide ions do you need? 6. 6 iodide ions. So in return, you're going to be left with 3 moles of iodine molecules to balance iodine. So you have balanced the equation right now. You have balanced the entire equation. So now you know if only 1 mole of chromate ion reacts, you get how many iodine molecules? 3 iodine molecules. 3. Now, if you look to the next part of the question, read the next part of the question. The iodine released is reduced back to iodide ions by X mole of S2O3 ions. Okay. 1 mole of iodine gas or iodine is reduced by 2 mole of S2O3 ions. So they've already mentioned, focus on this part, that 1 mole of I2 is reduced by 2 mole of S2O3, and it's going to give you 2I minus. Okay, so you need for each iodine molecule, you need 2 mole of S2O3. So for this reaction where you're getting 3 iodine molecules, for one chromate ion, how many S2O3 ions do you need? Now getting back to the initial question over here, they asked you to figure out for 3 mole of chromate ion. But we have figured out for 1 mole of chromate ion. So what do? We just multiply it with 3. And you're going to be left with 3 times 3, 9 iodine molecules. We have just multiplied the entire equation with 3 since it was already balanced, and now you're just including the fact that there are 3 chromate ions. So if there are 3 chromate ions, how many iodine molecules are going to be in the product? Times 3, which is 9. So we are starting off with 9 iodine molecules. The iodine molecules released is reduced back to iodide ions by X mole of S2O3. So you have 9 moles of iodine gas. So to reduce that, how many S2O3 ions do you need? For each of the iodine molecules, you need 2 mole of S2O3. So for using ratios for 9, you will need 9 times 2, 18 S2O3, 2 minus 18. So 18 is the answer. It's pretty lengthy. You need to do it in steps. And hopefully you'll get the answer. You can start off with, I started off with 1 mole of chromate ion because that's simpler to understand and simpler to balance. You can start off with 3 moles of chromate ion and balance it in the equation. And balance it the first step. But I did it the last step to keep it a bit more simple. Okay. Question 34. Chlorate 5 ions are produced in redox reaction between chlorine and hot aqueous sodium hydroxide. Okay. Oxidation numbers can be used to help balance the equation for this reaction. Chlorate ions are produced. Okay, they are the products in the redox reaction between chlorine, and hot aqueous sodium hydroxide. Sodium is a spectator ion, so they have not written that. They have mentioned only OH. Oxidation numbers can be used to help balance the equation for this reaction. Disproportionation reaction or disproportionation reaction. Okay. So chlorine is going from a net charge of 0 to either a net charge of -1 or a positive charge of +5. So for the first one, this is for reduction, I guess. Yeah, this is for oxidation. Chlorine is losing 5 electrons. If chlorine is losing 5 electrons for this part of the reaction, you're getting 5 electrons. Okay. And for another product, it's gaining 1 electron. It's gaining 1 electron. So half chlorine means 1 chlorine atom. 1 chlorine atom will gain 1 electron to give you Cl minus 1. But you had 5 electrons in the oxidation process. So if you have 5 electrons and you need to balance the number of electrons, you multiply it with 5. Which one? The reduction process, since there you only have 1 electron. So you multiply it with 5 and you will get 2.5 Cl2 plus 5 electrons and giving you 5 chloride ions. Giving you how many? 5 chloride ions. So X is going to be 5. So you can use that to deduct that C is the answer, because there are no other option with 5 as a value for X. We are not choosing the hydrogen ions and water molecules, since the values of Z and which one? W are not needed in the equation. You can figure it out simply by finding out the number of electrons lost or gained via the disproportionation reaction. If you want, you can include the number of water molecules and hydrogen ions in the equation and then do like one entire equation where you add all of the reactants and add all of the products, and you subtract the number of water molecules and subtract the number of hydrogen. And I have already done that in another video for another question, but for this one you don't need to do that, because you don't need the number of water molecules or hydrogen ions. It's easier if you just consider for chlorine atoms or chlorine molecules. So yeah, since we have received a value of 5 for X, C is going to be the answer. What is V? So V is actually the number of chlorine molecules, which is half plus 5 by 2, which is going to be 6 by 2. So it's going to be a value of 3. So V is going to be 3. And what is Y? Y. There is one chlorate ion. Where is chloride ion? In this equation. We have not multiplied this with any value, with any integer value. So there is only one chloride ion. So 1. So C is going to be the answer. 35. Which one? A carbon monoxide molecule, CO, has 3 bonds between carbon atom and oxygen atom. 3 bonds between carbon atom and oxygen atom. Which features are represented in one CO molecule? Okay. 2 lone pairs of electrons. 2 lone pairs of electrons. 2 lone pairs of electrons. CO. Yes. 2 lone pairs of electrons. Yep. And so basically there's a dative bonding where it's oxygen is giving one of the electron. Oxygen is giving one of the electrons. So this is being shared between, not really shared. The oxygen gives that electron to carbon atom. So there are only 2 pairs. 2 lone pairs of electrons, a coordinate dative bond from oxygen to carbon atom. Yeah. There is one dative bond where oxygen is providing carbon with 1 electron. 2 pi bonds. Yes. There are 2 pi bonds, since the first bond, since there are 3 bonds, triple bond. The first one is sigma, and the other two are going to be pi. The other two are going to be pi bonds. Okay. So A is going to be the answer where all of these are correct. Question 36. Okay. The volume of carbon dioxide collected by reaching 0.1 mole of magnesium carbonate by reacting 0.1 mole of magnesium carbonate, MgCO3, okay, with 50 cm cube of 1 mole per dm cube of sulfuric acid, H2SO4. This is measured against time. The volume produced is plotted against time and the line labeled P on the graph is obtained. The experiment is repeated using 0.1 mole of the same magnesium carbonate. The experiment is repeated using 0.1 mole of the same magnesium carbonate. So they have not changed the moles of magnesium carbonate. Okay. And a different sample of acid. All other conditions remain the same. Plotting these results gives the line labeled Q. What does Q represent? So the volume, the amount of CO2 released is more for Q. More CO2. The rate of reaction is less. Less rate of reaction. Okay. Less rate of reaction and more, double the volume or amount of CO2. Initially, there was, in both cases, for one thing, you have 0.1 mole of magnesium carbonate. In both cases, for both Q and P. However, in the first case, you have 0.05 times 1, 0.05 mole, 0.05 mole of H2SO4. 0.05 mole of H2SO4. Right. The experiment is repeated using 0.1 mole. Okay, that's all. Which sample of acid could give the line labeled Q? Now we have to figure out for which acid and which set of concentration and volume will give you double the amount of CO2. So what are we looking for? We're looking for an option where either it is still H2SO4 but double the mole, which would be 0.1, or a different sort of acid and a different set of volume and concentration to give you a different mole. So let's look at the different options. We have to get more volume of CO2. Okay, keeping that in mind, let's look at the first option, which is 100 cm cube, 0.1. 100 cm cube would be 0.1 dm cube times 0.5 would give you 0.1 times 0.5, 0.05 mole of H2SO4. Does that change anything? No, that does not change anything. So it's the same, it's the exact same. So that wouldn't affect, it would be still the same curve or graph. Next option. So A is not the answer because it's yielding the same amount of products. B, 100 cm cube of 1 mole per tm cube. If this is used, you're going to get 100.1 dm cube times 1, which is going to be 0.1. Now this is viable. Why? 0.1 moles of H2SO4 could give double the amount of CO2. So this seems viable. Alright, this seems quite viable. However, I mentioned in the beginning, the rate of reaction is different as well. In the initial case, 1 mole per dm cube of sulfuric acid was used. 1 mole per dm cube of sulfuric acid was used. And in the new case, where B is the option we are looking for or testing for, the same concentration is used when 1 mole per dm cube of sulfuric acid is used. However, rate of reaction does not change based on the volume, rather the concentration. So the rate of reaction depends on concentration. All right. But we have not changed the concentration. So how can B be the answer? Since the concentration remains the exact same, B cannot be the answer, as the graph is giving different rates of reaction. Even if the amount has doubled according to B and according to the option they have given, when it's giving you 0.1 moles, which is the exact double of 0.05 moles with the same reactant, even though it's giving you the same double the amount of CO2, you cannot choose this due to the exact same rate of reaction. You need a reactant or a different concentration, a different reactant or a different concentration where the rate of reaction would be different. Either the reactant has to be different or the concentration has to be different. Either of those two has to be different for you to get a different rate of reaction. All right. So B is not going to be the option. What is C? 200 cm cube of 0.5 mole per dm cube of hydrochloric acid. 200 cm cube would be 0.2 times 0.5, which would give you 0.1. 0.2 times 0.5, 0.1. So 0.1 moles of HCl. No. Okay. Interesting. So 0.1 mole of HCl will give you the same amount of CO2 as 0.05 mole of H2SO4. Can you guess why? The main reason is HCl is giving you 1 H plus ion. The acid is basically the proton or the H plus ion. But H2SO4 is giving you 2 H plus ions. Since this is more acidic and giving you 2 moles of H plus ion, at the end of the day, even if HCl has double the moles, H2SO4 is giving you double the number of H plus ions. So at the end of the day, you have 0.1 mole of H plus on this side and 0.05 times 2 giving you 0.1 moles of H plus as well. So you're going to get a different curve. Is it going to be different? Yes, it's going to be a different curve where the rate of reaction will be slower. It's going to be much slower than P. However, it's going to yield you the same amount of products. So why is the concentration much lower? Because initially there was 1 mole per dm cube of H2SO4. Now you have 0.5 mole per dm cube of HCl. For one thing, the concentration has decreased and the reactant has changed as well. And due to the decrease in concentration, the rate of reaction will decrease. Plus, HCl is only contributing by giving you 1 mole of H plus ion. Whereas H2SO4 used to give you 2 moles of H plus ions. Since the concentration of H plus ions is much less in this option, the rate of reaction would be much less as well. But even if that is true, the amount of CO2 is not doubling. Which is why C is not going to be the answer. D. 200 cm cube of 1 mole per dm cube of HCl. Okay. 200.2 times 1.2 moles. Okay. So initially you had 0.05 moles of H2SO4. You had 0.05 mole of H2SO4. So how many hydrogen ions? You would have 0.1 mole of H plus ions. In the new case, in the new option, you have 0.2 moles of, right? 0.2 moles of HCl. How many hydrogen ions does HCl contribute by? 1. So you have 0.2 mole of H plus ion. So in this case, yes, the amount has doubled. The amount of H plus ions have doubled. The amount has doubled. So the amount of CO2 will increase as well. The amount of CO2 will increase as well. Okay. So since the amount of CO2 will double, this could be an option. The other thing to notice is the concentration. Is the concentration different? Even though initially it was 1 mole per dm cube of H2SO4, and now it is still 1 mole per dm cube of what? HCl. The concentration of acid is different because it's giving you 1 mole per dm cube of H2SO4 is giving you 2 mole per dm cube, 2 mole per dm cube of H plus. But 1 mole per dm cube of HCl is only giving you 1 mole per dm cube of H plus. Since the concentration of acids are different, H plus ions, the rate is going to be different. Since the concentration is less of the acid, of the H plus ions, the rate of reaction will be less. This is why D is going to be the correct option, where the rate of reaction is less and the amount of CO2 is more. This is why D is the right option. I hope I could explain this. It's a bit complicated, but yeah. Okay, question 37. Ethanoic acid HOOCCOOOCOOH can be oxidized by potassium manganate in dilute sulfuric acid. The products of this reaction are carbon dioxide, water, potassium sulfate, and manganese sulfate. Okay. In this reaction, each ethanoic acid molecule loses 2 electrons as it is oxidized. A half equation for this process is shown. Okay. How many water molecules are produced when 5 ethanoic acid molecules are oxidized by KMnO4 in dilute sulfuric acid? Okay. So each ethanoic acid, when oxidized, is releasing 2 electrons. 2 electrons. How many electrons will it release if 5 moles of ethanoic acid is oxidized? 5 times 2, 10. 10 electrons. Now we know we have 10 electrons to deal with. Okay. So, how many water molecules are produced when 5 moles of ethanoic molecules are oxidized by KMnO4? Okay. So when manganate is being reduced, when manganese is being reduced, it is producing water molecules. It is producing water molecules. Okay. When this is being oxidized, it's producing 2H plus ions, and when manganese is being reduced, it's producing water molecules. So let's balance it first. Manganese will be gaining how many electrons? It's going to turn into Mn2 plus. Manganese sulfate. Manganese sulfate, this is manganese sulfate. So manganese has a charge of 2 plus. That's why Mn2 plus. Sulfate is spectator ion, so we have not written that. Okay, so manganese will be gaining, what is the charge of manganese over here? Minus 2 times 4, which is minus 8, plus 7. Plus 7. So manganese is going from plus 7 to plus 2. How many electrons is it gaining? 5. Great. So it's gaining 5 electrons. Now, if we balance the equation, MnO4, you have 4 oxygen atoms on the left hand side. You need 4 oxygen atoms on the right hand side. So what do? You add 4 moles of H2O. Why? You need 4 moles of oxygen. So since you have added 4 moles of H2O, you need 4 moles of hydrogen ions on the left hand side. Sorry, 4 times 2, 8 moles of hydrogen ions on the left hand side. So 8H plus. Okay, so if we do that, we're going to be left with 4 moles of H2O, but you have 10 electrons. But here, manganate is only gaining 5 electrons. So what do? You multiply this entire thing with 2. Why? So that manganate, 2 moles of manganate gains 10 electrons. 5 times 2, 10 electrons. That way, the entire equation is balanced. In which case, 4 times 2, 4 moles of water molecules, 4 times 2 is going to give you 8. So, 8 is the answer. 8 moles of water molecules are going to be released. Okay. So, you might have a question that why haven't we introduced any water molecules for this oxidation process? Because they've already given you the equation. They've already given you the equation for oxidation. So we are not changing any value or adding anything in this equation. Because they've already given you the oxidation equation. But for manganate, they have not mentioned anything. So we have to add water molecules to balance either side of the equation, or specifically to balance the oxygen atoms, which is why we are adding the water molecules. Or else the number of oxygen atoms are not going to be balanced. And when we add the water molecules, we have to add H plus ions on the left hand side. Why? To balance the number of hydrogen atoms. So that is how you can figure out how many water molecules are being produced. If you add these two reactions, you're going to be left with 8 minus 2, 6 hydrogen ions on the left hand side. 6 hydrogen ions on the left hand side, and 2 MnO4, and 1 mole of ethanoic acid. HO2CCO2H, and you will have 10 electrons, and on this side you will have 2 Mn2 plus 8 H2O
plus, we have already cancelled H plus. So 2 CO2, no, 10 CO2, 10 CO2, 10 CO2 and 10 electrons. Okay, 5 moles of ethanidioic acid. Okay. Yeah. This thing is now the entire equation. You can cut the electrons out. You're going to be left with this and this, which is the main equation, the ionic equation. The 2 and 10 were used to balance the number of electrons. So this, you had initially 2 electrons over here and 5 electrons over here. To make it 10, we have multiplied with 5 or 2 to make the total number of electrons in each case in oxidation and reduction 10. That's why we have multiplied by 5 or 2 to balance the number of electrons. Okay. Yeah. Question 38. 17.6 gram of pentan 1-ol is completely combusted. Which volume of gaseous products is formed when measured at standard temperature and pressure? So you should know this. I don't know if this is given in the question paper. It might be in the data booklet, but you should be aware of this value. Is it 273? 298? Wait, let me check. Okay, yeah, so it is 273 Kelvin. 298 is for room temperature, I guess. Yeah. So 101 into 10 to the power 3 Pascal is the pressure, standard pressure. Okay. Which volume of gaseous products is formed when measured at standard temperature and pressure? 17.6 gram of pentan 1-ol. So you need to know a bit of organic chemistry to answer this question. Basically, pentan 1-ol is an alcohol, 5 carbon atoms. 3, 4, 5. This is pentan 1-ol. So if you have 17.6 grams of it, you basically find out the moles. 17.6 divided by how many carbon? 5. So 12 into 5 plus 12 plus 16, you get 0.2 moles. It is combusted, so it reacts with O2 and it forms 5 CO2 to balance 5 carbon atoms, and you have 6 H2O. Since it's a combustion reaction, water will be produced. After you have balanced, this is what the balance equation looks like. And which volume of gaseous product? So the gaseous product is going to be CO2. Since you have 1 mole is to 5 moles, that's the ratio, 1:5. If 0.2 moles of pentan 1-ol, is it pentan 1-ol? Yeah. If 1 mole of pentan 1-ol is combusted, 0.2 moles of pentan 1-ol is combusted. 1 mole, 0.2 times 5, 1 mole of CO2 will be produced. 1 mole of CO2 will be produced, which is, you could guess 24 dm cube. You would guess 24 dm cube, and that would be wrong. That's the trick question. They have specifically mentioned STP, standard temperature and pressure, which is different from RTP, room temperature and pressure. RTP is 298 Kelvin, and I guess pressure is the same. I don't really remember. But yeah, RTP is different from STP, and you have to consider that when plugging it into the PV is equals to NRT equation. You could have guessed since it is 1 mole, it's going to be 24 dAq, but that's not right since they have mentioned standard temperature and pressure, which is different from room temperature. So this is why you have to use this equation, and you know the pressure, which is 101 10 to the power 3. You don't know the volume. That is what you have to figure out. N, you know 1 mole. Reaction constant is 8.3 always. Temperature is, if you're doing it in Celsius, what are you doing it? If it 273 Kelvin. Okay, so it's supposed to be this most likely. I'll check. 101 into 10 to the power 3 divided by 8.31 times 273. Okay, so it's going to be 273. Yep. And 0.002246. Okay. So if you convert that into dm cube, from meter cube to dm cube, you're going to get 22.4 by 1000 if you multiply by 1000. Okay, so 22.4 is the answer. So you need to be careful about the conditions they mentioned, and if it's different from room temperature and pressure, you need to use this equation. P is equals to nRT. Okay. Question 39. A 3.7 gram sample of copper 2 carbonate is added to 25 cm³ of 2 mole per dm³ of hydrochloric acid. Which volume of gas is produced under room conditions? Copper carbonate, copper 2 carbonate, CO3, reacts with 2 moles of HCl, 2 moles of HCl, okay, producing what? CO2. Yes, CO2, H2O. Yes, H2O, and a salt. Okay. Okay. Is this balanced? Cl2. You have to add 2, yeah. 2 HCl, 2 HCl. Yeah, it's balanced. Which volume of gas is produced under room temperature and conditions? Under room conditions. See, now they have mentioned room conditions, which is different, which is 298. So, what is that in Celsius? 25, I guess. 298 minus 273. 25 degrees Celsius. Okay. Under room conditions. 3.7 grams. So, figure out the moles. Which is going to be 3.7 divided by there. It's going to be 0.02996. Okay. 0.03, let's say. 0.03. Okay. So if we say it's 0.03 and it's reacting with 2 moles of HCl. Oh, so 2 moles of HCl will only react with 1 mole of CuCO3. 1:2 ratio. So, the amount in moles required for CuCO3 is only going to be 0.05 divided by 2, since 1:2 ratio is going to be 0.025. Yeah, 0.025. But you have 0.03. You have CuCO3 in excess by 0.005 moles. So you have to use this value to determine how much gas is produced, not this. You could have used 0.03 to determine the amount of gas, but you would have received a wrong value. So if you use the moles of HCl, and they have already mentioned the volume and concentration to get the moles of HCl. So yeah, if you get the moles of HCl, use that ratio 2:1. So it's going to be 0.025 again of CO2 that is going to be produced. If 0.025 moles of its CO2 is produced, it's going to give you 0.025. Now you can multiply it directly with 24 TM cube since they have mentioned room conditions. Times 24, it's going to be 0.6 GM cube. So yeah, be careful about the conditions mentioned. If it was not room condition and standard temperature and pressure, you would have to use PV is equals to nRT again and figure out the values. So yeah. Okay, question 40. In a catalytic converter, 5.6 grams of carbon monoxide react with an excess of nitrogen monoxide. What is produced in this reaction? So they've already mentioned catalytic converter. Not in any random equation, but in a catalytic converter. What is the product going to be? What is the product going to be in this reaction? So specifically for a catalytic converter, the purpose of the catalytic converter is to oxidize carbon monoxide and reduce nitrogen oxides. So it's not going to be this equation. Even if you're going to get the value, or you're going to get the values for option B is not going to be the answer, because the purpose of a catalytic converter is not to produce carbon atoms and NO2. The purpose of catalytic converters are to produce CO2, carbon dioxide, and nitrogen gas, only nitrogen gas. So this would be wrong. B would be wrong, A would be wrong. So for D, if you react CO, carbon monoxide, with NO, and once you balance it, you're going to see it produces 2 moles of CO2 and 1 moles of N2. So you have 5.6 grams of CO, carbon monoxide, which is 0.2 moles of CO. You divide 5.6 by the molar mass, which is 12 plus 16. You get 0.2. The molar ratio is 2:2. So 1:1. 0.2 moles of CO2. 0.2 moles of CO2 mean 0.2 times 12 plus 16 into 2. 0.2 times 12 plus 16 into 2. 8.8 grams. And again, 2:1. So the mole is going to be 0.1. 0.1 means 0.1 times 14 into 2. Since N2, 14 into 2, 14 into 2. It's going to give you 2.8 grams. 2.8 grams. Not 0.1, not 1.4. 2.8 grams. So D is the answer. Alright, that's the end. I have 8 more questions for physical chemistry, and I'll do those in the next video. Bye.